Hello, we're going to look into the second question, and this is going to be focusing on a core practical of metals, that is to determine the formula of metal oxide by reduction. The idea of reduction here is very simple. It is to remove the oxygen from the metal oxide, and what we get at the end of the day is just the pure metal. So without further ado, let's dive into this 12-mark question. Shall we get going? Alright, so this is the setup. What we have is we are blowing hydrogen gas into metal oxide and we get the pure metals. But to help you visualize a little bit, we could have a metal oxide such as, so we start with a metal oxide, something like copper oxide, and we blow hydrogen gas into it. What we get at the end of the day, or the aim of this objective, is to get the pure metals, okay, and the side product of steam. Okay, it can be steam, it can be water, really depending on how hot things are. Okay, but the idea here is to actually reduce a metal oxide to a metal. That's what we want. Okay, so so there's a few things. Okay, the weight of the empty tube, the mass of the tube, and metal oxide are recorded. Let me just change it to yellow. After heating, the tube is allowed to cool and the mass is again recorded. Okay, so for A part 1, state why the reaction of metal oxide to form a metal is described as a reduction reaction. So you need to know the idea of redox over here. And here we are focusing on the first word, which is reduction. Reduction has two meanings. One is loss of oxygen, and the other one is gain of electrons. So obviously here there's no mention of electron, although if you can work out the oxidation state, you would be able to identify this. But the clearer sign is to be able to tell that the metal oxide eventually becomes a metal. So the metal oxide is losing oxygen. So what are the things to take note? The first and most important thing is it is the metal oxide that is losing oxygen. It is not metal losing oxygen. So this alone will not get you any marks because we don't start off with a metal, we start off with a metal oxide. So metal oxide is the one losing oxygen. So take note of that. This is 1 mark. Next, we look into part 2. Okay, state why is it important to relight the hydrogen at the end of the tube if the flame goes out. Now the idea here, there's a safety aspect. This is a practical question, so you need to consider why is it dangerous to have hydrogen, or what's the safety aspect of relighting the hydrogen at the end. Basically, I want to burn off all the hydrogen. Why is that so? It's because hydrogen here is a flammable gas. So what does it mean here is should I change it to another color? Yeah, probably change it to something lighter. Okay, hydrogen is a flammable gas. So if there is still hydrogen escaping into the environment, and the thing is hydrogen is colorless and odorless, so in the presence of just a spark, it will cause an explosion. So here you need to consider the safety aspect of things. Okay, so hydrogen is a flammable gas. What other flammable gas are there in chemistry? Will be methane. Okay, so take note of this. So this is the reason why. Okay, part 3, explain why it's important to continuously pass hydrogen into a tube. So why is there a need to continuously pass hydrogen into the tube, right? Until the contents have been cooled. So what is it about the content that you do not want other things to mix with? Now, at the end of the day, you want, if the pure metal is already formed, right? Pure metal is already formed, and you stop pumping in hydrogen gas, what's going to happen is the surrounding air around us, we have oxygen, isn't it? So the oxygen would react with the pure metal, and then it will form back to its original. So you don't want that to happen. You want to make sure that while the content is being cooled, while the metal is being cooled, there is no other air that's coming in contact with it. So the idea here is to stop the oxygen from the surrounding from entering the tube. So why it's important, why is it that we do not want oxygen to enter the tube? Is because if not, the metals would change back to metal oxide, or rather you could say the metal would be oxidized back to metal oxide. And so it defeats the entire purpose of this practical, isn't it? If not, you have to keep redoing and you won't be able to get your pure metal. Okay, so again, hydrogen is continuously pumped in to make sure that the pure metal that you get, remain as the pure metal while it's being cooled and not turn back into metal oxide. Okay, so I would say part 2 and part 3 is considered a hard question for a lot of students, mainly because this is a practical they don't really get to do in school. Usually it is substituted by a video. So consider the safety aspect for hydrogen, and using the data provided, you could probably work out part. But for part 4, we are supposed to describe what should be done next to ensure all the metal oxide has been converted to metal. This is quite well done because most students would have memorized this answer. Okay, you want to make sure that the reaction is complete. You want to reheat until you obtain a constant mass. This is quite common. During my summer revision package, I also come across a few practical questions, and this is a very standard answer. So in order to make sure, or how do you make sure that the reaction is complete, how can you tell, is that you actually achieve a constant mass. And how you're going to achieve a constant mass is you heat it until you don't get a change in mass. Alright, next one. We have a part BI. Here is a mole concept question. Okay, so first question here is you start off with this. You obtain 4.14 mass of metal from this mass of metal oxide. Okay, then what happened is you would want to calculate in moles the oxygen atom in this sample. So the first thing you want to do is to find out what is the mass of oxygen in this sample. So you use the answer in red minus, so I'm going to use this, 4.46, subtract 4.14, ooh, okay, and you get a mass of 0.32 gram. Okay, that is the mass of oxygen. And based on our mole concept, mass, mole, MR or AR, okay, AR here refers to the mass of an element, okay, and MR here refers to a mass of a molecule. Mass of, okay. So here, in order for us to find the mole of oxygen, okay, I have to use mass divided by the AR. So the mass is 0.32, and then the AR for oxygen is 16. You do need to go to the periodic table to find this because it's not given. But unfortunately, there are some students who put 32 instead of 16. And why is that so? Is because they treat oxygen as O2 gas. This is only when we're talking about oxygen gas. Okay, but if you're talking about the element oxygen, it's only 16. So you end up with 0.02 moles. And this is 2 marks question, so only 2 working steps. Next, we are looking at this question here. They say the formula of this metal oxide, it begins with the formula M and O, where M represent a metal. So we could have metals like, if I were to give a standard example, it would be magnesium oxide, whereas where the ratio of magnesium to oxygen is 1:1. Okay, that's what it means, MO. But it doesn't mean that this metal here is Mg. Okay, it's not magnesium. We're just using M to represent this particular metal. So the ratio of magnesium to oxygen is 1:1. So from the previous question, we already know that the number of mole for the oxygen is 0.02. So this question is asking, deduce the amount in moles of M in this sample. So if the ratio is 1:1, that means if my number of mole for oxygen is 0.02, then obviously the number of mole for this metal is going to be the same, isn't it? So the value of the number of mole of this metal is the same as the number of mole of oxygen in this case, so 0.02. Alright, next one, we want to find the AR. So we use mass divided by number of mole. So the mass of the metal is given in the question, like here. We end up with this mass of metals, 4.14, and we divide by the number of mole, which is over here, the previous part of the question, and we get 207. Now, if you have memorized your periodic table well, or like me, have used it for more than 10 years, you would know this number belongs to the AR of a particular metal that's very dense, and this metal would be lead. So if you're not sure, and of course, I don't expect you to remember all the mass number of all the elements, right? It's just like, if you have used it enough, okay, you will have C207. But even if you don't, the periodic table will always be provided. Go to the periodic table and identify the metal with a mass number of 207, and you'll be able to find lead as the answer. Okay, so this is a 12-mark question. It is essentially a slightly difficult one because of the mole concept involved in it. Okay, but with a little bit more practice, this should be quite easily conquered. All right, I'll see you in the next question.